When modern servers run at peak capacity, the computing hardware is subjected to intense physical and thermal pressure. This 3D wireframe models a complete thermal stack, a silicon die, a 30-micron interface matrix, and a copper cold plate. Finite element analysis subjects this assembly to an instantaneous global thermal shock, spiking from a 20-degree baseline up to 100 degrees Celsius. Under this jump, maximum physical displacement registers at 4.42 microns. That expansion generates a severe physical load, recording a structural shear force of 361.7 megapascals. Key findings in telemetry. The simulation analyzed how the physical forces in expansion from this severe 80 degrees Celsius temperature jump affected the materials. Minimal global displacement. Under the simulated 100 degrees Celsius thermal shock, the absolute maximum physical displacement across the entire assembly registered at only 0.00442 millimeters, 4.42 microns. This extreme dimensional stability proves the Hyg-Z-001 matrix can successfully absorb the differing expansion rates of rigid silicon and dense copper without causing structural failure or logic board warping. Von Mises stress isolation. The von Mises stress map visually confirmed that the maximum structural shear stress, 361.7 megapascals, was safely isolated entirely within the massive, rigid structure of the copper cold plate. Critically, the Hyg-Z-001 interface and the fragile silicon die remained protected in the lowest stress registers. Zero plastic strain. Because the hydrographene's biomimetic nanospring architecture is highly compliant, it absorbs mechanical stress elastically. The Phi solver completed the calculation with an equivalent plastic strain, PEEQ, of exactly 0.000, confirming zero permanent structural deformation. Life cycle implications. In legacy server architectures, this exact CTE mismatch creates abrasive shear forces that cause thermal pastes to rapidly pump out and delaminate over time. Because the Phi mathematical models prove the Hyg-Z-001 matrix maintains a perfect zero plastic strain elastic response under maximum thermal shock, it is verified to be completely immune to this pump-out effect. This ensures uninterrupted, atomic-level thermal contact for the entirety of a standard 5 to 6 year, 1000-plus cycle server deployment.